Hello everyone, welcome to another session on the slice. So in the last session we have seen a couple of ways to create slices, and we have also seen what does a slice contains internally, and we have also observed what happen when you create a sub-slice out of a slice, and those inferences we have noted it down in the line number 18 and 19 here, as you can see. And in this session we will see the subtle difference between the length and the capacity here. The first parameter here is the length, and the next one is the capacity of the slice. So we'll see the differences between them, and we'll also try to cover an important function of slices, which is called append. Uh, let's go ahead and get started. So if you can see the subslice here, it contains elements 2 and 3 inside it, which includes it contains elements 2 alone inside it. We'll make it 3. So what does it mean is, actually it contains both these two elements, starting from 1 include and up to 3 excluding 3, the third element. So let's try to print it and see what happens in this subslice. So you could see that both 2 and 3 are here. Let us also see its capacity and this on the size of this, and the length of this. So the length is length of there is an inbuilt function where you can pass slice to the length function, and in the same way you can get the capacity as well with the capacity function, and we'll try to see what is there in this length and capacity. So if you can see here, the 2 and 3 are being filled up, and the length is 2 because there are only 2 elements into this, and the capacity is 4. So why is it 4? Because the original slice is having the capacity of 5, and when you slice it up, the subslice is pointing to the first pointer of this original slice, and from there on the capacity is 5 elements, which is the remaining elements in the same array. So basically the slice contains an array something like this: 1, 2, 3, 0 and 0. So the subslice SL is actually pointing to this. So, and it has only 2 elements, and the capacity is 4 from here to the end of the array. So that's what it is. So we'll do another interesting experiment. Instead of slicing the subslice, we will try to make the subslice for the whole capacity, which is 5. So instead of writing 5, we will use the capacity of slice itself, the same, and we will try to see what changes are going to happen with this printing the subslice with the length and the capacity. Okay, so if you can see here, the slice actually prints everything from the elements, that is from here to here, and the length become 4 because you have already included the elements which are empty in the array as well. The capacity is obviously going to become 4. So earlier it was 2 and 4, now it is 4 and 4. So if you are including the whole capacity, the problem with the subslice is you do not know, whenever you are iterating through the slice, you do not know whether these two elements at these two indices are actually inserted by the user or by the programming logic, or it is the default value that is available with the capacity. So that's the problem with this. So what you generally should be doing is either you leave it to this end, that means it goes to the length of this length of the slice. Now if you can see, you can see only 2 and 3 here. The capacity is still 2. Or you can also say that length of the slice, which is from here to here, which is the 3. I'm sorry, let me run this. Okay. So that is what it is. You can see 2 and 3 now, the zeros are gone. Let us try to write the inferences out of the experiment that we have done. So in a given slice, length is the number of filled elements, filled indices out of the array capacity that the slice holds. So now capacity is something that starts from the first element of the index of the slice till the end of the array that it holds. So I hope this inferences sound reasonable with what we have understood so far. And so now let us start looking at the new append function. So I'll create a new slice, so which has a length of 3 and capacity of 3. Looks good. And so let us try to add elements to this new slice. New slice of 0 is 1, 2, 1 and 2, 2 and 3. Let me comment out all this code so far so that it does not disturb our print statements that we are going to add. So it's all commented out now. Now let's first print this new slice. Okay. Great. It's printing 1, 2 and 3. Now what happens if we try to add a new index which is not available as you expected? It will panic out, so it fails, so which is very much expected. So but there is a way in that Golang offers us to use a function called append function. So append function will simply add elements that you are going to add uh, to the slice. So what all you need to do is you need to pass the slice to which you wanted to add the elements and then add your element, and you can add multiple elements, 4, 5 and so on. Okay, now and the return will try to save in the same new slice. Okay, we'll make some experiments. Okay, we need to print. So so 1, 2, 3 and 4. So in the earlier time when we try to add a new element in the new index which is not available, which is 4, and it didn't allow us to add it to the third index, but in this case it simply adds it. So what happens internally? So basically what it does is, so it creates a copy of this new slice and create altogether a new array internally, and then copy all the elements with the new capacity and length to the new slice and return back the new slice. So let us try to prove this theory. Okay, now how do we prove this? So just as we do earlier. Before printing, instead of printing new slice, what we'll do is we'll try to print the address of the first element in this new slice, which is %p and /n. All we need to do is new slice of 0, and we'll do copy the same thing, new slice of 0. So with the append function, if it is copying to a new array altogether by increasing the array size, so it has to print two different address spaces now. So we'll try and see. Okay, it's okay. We missed the ampersand symbol here. Okay. So why is it printing 2, 3? Did I miss anything here? Okay. Okay, printf. We need to format it, not just print it. Okay. So if you can see here, these two are two different address spaces. So that's what it is. So what happens to the capacity now? So the initial capacity is 3, right? So what happens to the capacity? We'll try and see that as well. So d dot println capacity earlier, that is cap of new slice, and try to do the same here, capacity now. So the capacity earlier is 3, now the capacity is 6. So what it means is whenever you try to add a new element which is beyond the slice capacity, it multiplies with a factor of 2 and then create a new array and copy the elements from the older array to the newer array and append it to the newer slice. So it's as simple as that. So you should use append carefully, and it's good to have more capacity at the earlier while declaring the slice itself, and so if you are working with larger set of elements, of course there is no other way, it has to do the copy. But if you know earlier the maximum capacity that the slice should hold, declare it as much as you can, and keep appending the elements to it. So if it doesn't go beyond the capacity of this initial size, it is not going to create a copy until it fills up the whole array. So that's it for today, and thank you.